We have two types of problems we're dealing with here. We have parallel problems and perpendicular problems, and we're forcing it to go through a point. What is an equation of the line that passes through, it has to pass through this point and is parallel to this line right here. All right, so I always recommend that if you have a vocabulary word that's one of our terminology referencing a formula, that we write out the formula. So out of all of this, what is the formula that we want to kind of pull out as our foundation? Equation of a line. Equation of a line has a formula. So what is the equation of a line? Usually we would have it in slope-intercept form. Y equals mx plus b. We have to use this one because this one gives us our slope. Our slope and our y-intercept are the two things that we need here, but the slope is most important because slope is what tells us if something is parallel or not. It has to be the same slope and it has to have a different y-intercept. If it's the same slope and same y-intercept, it lands on the line, and that wouldn't be parallel. So we have to make sure we have that one exception. This point right here forces it to be something different. So what do we do? How would we kind of approach this one? Well, if you notice, the line that we're referencing here is not in slope-intercept form. So we don't even know what slope we're looking for. That's going to be our first step. So let's go ahead and find out the equation of the line that we need to compare. So I'll do it right here. X minus 2y equals 6. The strategy goes, get y by itself. Move everything that's not a y to the other side. So that would be minus x. We got negative 2y equals negative x plus 6. Then the last stage is to get y by itself. We divide by negative 2. So divide by negative 2, divide by negative 2. All right, so negative 2's cancel, and we get y equals. Now, when you do this, this goes to each of the numbers, each of the terms, not numbers, each of the terms get to divide by negative 2. So what's the first term? Negative x divided by negative 2. That's going to be x over 2. And what's the second one? Negative 6 divided by negative 2 is a negative 3. We want to write it in this form where we can see the slope. So a divide by 2 is the same thing as a multiply by 1/2. It's like you're moving it out front. All right, so there's the equation that we're kind of comparing. And that means we have to match the slope. The slope matches, and we're using this point here. Okay, so how would we find an equation using this point here and that slope? It's your foundation again. So you're using this equation. All right, so this is your x. This is our x. This is our y value going into here. There's a couple different methods, but usually we just plug those in, and this one is our what? That's our m. So we plug these numbers in along with that m, and that should give it to us. I'm going to go ahead and switch back to red so I'm a little more clear. All right, so what's the y value? Let's go ahead and rewrite the form. Just y equals mx plus b is our reference. All right, so what's our y value? Negative 8 equals. What's our m? 1/2. What's our x? Negative 6. What's our b? That's what we're looking for. Remember, if you only have one letter in your equation, then that means you can isolate that letter and solve for it. So we only have one letter, the b here. So we need to do our order of operations, simplify, and we're done. Almost. So 1/2 of negative 6. So that would be negative 8. I'll just show my work. A number times a fraction goes to the top, negative 6 over 2. You could have just halved it if you know that. Negative 8 equals negative 3 plus b. Add 3, negative 5 equals our b. Are we done? No, remember, we want the equation of a line. What is the equation of the line? So, plugging all this in, lastly, remember, these are your parameters. These are what you're looking for. X and Y are variables. So we keep our variables. Y equals m is 1/2. X is we keep X, and we have the minus 5. And then if you wanted to, if this were a test, I would definitely check my work. So we have the same slope, check. We have a different y-intercept, check. And if I plugged in negative 6, negative 8, half of negative 6 is negative 3 plus negative 5 is negative 8. So that does check out. Y equals 1 divided by 2, x minus 5. Fair work. You have to take that equation, solve for y. There's the slope. Looks like they're using the same strategy as I did, and plug everything in. And they even graphed it so you can see what it looks like, what it means to be parallel. All right. Next one. We want a different type of problem. So those are the parallel problems. The other type you'll see are the perpendicular problems. All right. So what is an equation of the line that passes through the point 7, negative 7 and is perpendicular to the line right here? All right. So you remember the strategy and the steps? All the steps are exactly the same. It's just we have to use the fact of what parallel and perpendicular mean to the slope. So what did I do first? Equation of the line. That has a formula. We write the formula out. And then that means we need this equation to match this form so we can see what the slope is. Minus x, move everything that's not a y to the other side. Y needs to be by itself. What you do to one side, you do to every other side. Every term gets divided by negative 2. So that now gives us y equals, that's going to be x over 2 minus 1. Move that denominator out in front so we can see what the slope is. All right, so we need a perpendicular line to this one. So this slope is 1/2. We have to know what perpendicular means. That means we change the sign. Which is called opposite. And what's the other thing we have to do? We have to flip the fraction. We have to make it into a fraction. If it's not a fraction, that's called reciprocal. All right, so we do the opposite reciprocal. We change the sign and flip the fraction of the what? Of the slope. All right, so that means our perpendicular slope, so it's like an upside down T that shows like a perpendicular line, is going to be equal to what? Negative 2. Flipped it, changed the sign. That's positive. All right, so then start off with the equation of a line, y equals mx plus b. Plug in our parts. This is the x value. This is the y value that we're going to use. So y is negative 7. Negative 2 is our new slope. That's perpendicular to the original. X is 7. And B is what we're looking for. Remember, M and B are our parameters or the numbers that we need. X and Y are variables. They stay the same. All right, simplify. Negative 7 equals negative 14. Add 14, add 14, and we get 7 equals B. What's the final step? Don't forget to answer the question entirely before moving on. Equation of a line. Y equals negative 2 is the slope we're using. X is our variable. 7 goes at the end, matching this form. That should be everything. Y equals negative 2 X plus 7. All right. That's going to be your strategy on these. Looks like they're doing exactly the same. All the same steps. Okay, and then they're showing what the graph would look like. All the problems will be similar to these.